In this video, we will discuss apportionment and voting. The mathematical investigation into apportionment, which is a method of dividing a whole into various parts, has its roots in the U.S. Constitution. Since 1790, when the House of Representatives first attempted to apportion itself, various methods have been used to decide how many voters would be represented by each member of the House. The two competing plans in 1790 were put forward by Alexander Hamilton and Thomas Jefferson. There are three methods of apportionment, namely the Hamilton Plan, the Jefferson Plan, and the Huntington-Hill Plan. Under the Hamilton Plan, the total population of the country is divided by the number, which is called the standard divisor, of representatives that gives a number of citizens represented by each representative. The standard divisor is the number of people or voters represented by each representative. And to compute that, we have the total population divided by the number of people to apportion. We also have the standard quota. It is the whole number part of the quotient when the subgroup population is divided by the standard divisor. To use the Hamilton method or Hamilton plan, we will compute the standard divisor first and then calculate the standard quota rounded to the nearest whole number. Initially, each subgroup receives a number of seats equal to its lower quota. If the sum of the lower quotas equals the number of seats to be apportioned, the apportionment process is complete. But if the sum of the lower quotas is less than the total number of seats to be apportioned, then assign a seat to the subgroup that has the highest decimal part in its standard quota. We will just repeat step number 3 until the total number of seats has been apportioned. To illustrate the Hamilton plan, we will consider the following example. Barangay Dologan is composed of 4 clusters. There are 350 sacks of rice to be apportioned among the 4 clusters according to their respective clusters' total population. The population in each cluster is given in the following table. Find the standard divisor and standard quotient of each cluster. So let us compute for the standard divisor first. Standard divisor is equal to total population divided by the number of people to apportion. And in this case, the total population is the sum of the population, and this is equal to 5,250. Divided by the number of people to apportion, and in this case, we have 350 sacks of rice to be apportioned. Using your calculator, and this is equal to 15. So our standard divisor is 15. So basically, we will just get the quotient for each cluster. Using the formula for the standard quota, the population of the subgroup divided by the standard divisor. So we have 1,250 divided by 15, and that is equal to 83.33. And if we round the quotient down to a whole number, so we have the standard quota equal to 83. Next, 985 divided by 15, and that is equal to 65.67. Round the quotient down to a whole number, we have 65. Next, we have 1,420 divided by 15, that is equal to 94.67. Again, round down to a whole number, and we have 94. For the next and the last cluster, we have 1595 divided by 15, and that is equal to 106.33. And if we round down to the nearest whole number, we have 106. So if we sum this up, 83 plus 65 plus 94 plus 106, it will give us 348. And if we recall from the problem that we have to apportion 350 sacks of rice, and after step number 2, the sum is less than the total number of sacks of rice to be apportioned, we will assign the remaining sacks of rice to the cluster with the highest decimal part in the quotient. And from these quotients, the highest decimal part are the clusters west and south. The standard quota will be given extra sack of rice. So we have the final 83, 65 plus 1, 66, 94 plus 1, 95, and 106. And if we sum this up, this will give us 350. And the apportionment process is complete.